Now that we've already deployed this smart contract on local and we understand what it's supposed to do as a part of testing the contract, the next steps are easy, where what we want to do is we want to see it running on the real blockchain. So for that, let's first get to the original state. To be able to connect to one of the testnet environments, we'll need to understand two components. One of them is MetaMask. So MetaMask is a browser plugin that I've just launched. It's got this cat icon, and what MetaMask does is it connects to a blockchain node that directly connects to the blockchain and is completely up to date with all the transaction and blockchain state. So it is a convenient means for me to connect with a blockchain node and send my transactions without having to host a node on my system directly. Now what you'll see is that it gives me an ability to connect with different networks, and what these networks mean is that it's an entirely different blockchain group or blockchain instance that represents certain versions and a certain distributed network. So we are connected to Ethereum. We've got the Ethereum mainnet, which is the real Ethereum blockchain that has the Ether cryptocurrency. And then we've got these number of testnets. We've got the Ropsten testnet network. We've got Covan, which is what we'll use. We've got Rinkibai, and then we've got Goerli. So all of these four are different types of testnets that are available for us to use. Now I am connected to the Covan network. What I also have is the ability to load an account. I have number of accounts configured in MetaMask. I will pick the one that has some ethers on the Covan testnet. So there are a lot of other features on MetaMask, and MetaMask essentially is a very powerful wallet that's very popularly used in the Ethereum community. But I'll not go further into those features because our objective is to understand the smart contract deployment process. So this is one of the components that we have to understand. It will help us sign transactions before we send them to the Ethereum testnet. The other component is Etherscan. Etherscan is a website, but it represents a very powerful blockchain explorer that's going to show all the activities on a specific blockchain environment. So we are in the realm of Ethereum, so we will talk about the Ethereum environment. So when you go to the website directly, it is going to show you the matrix or transactions and blocks of the Ethereum mainnet. So these are the blocks, these are the transactions. As transactions are coming in, they are getting added. But we have to go to the testnet, and it allows us to do that also. So the name of our testnet, as I had shown in MetaMask, is Covan. So all I have to do is just add Covan to the URL, and then I'll get to the Covan environment with transactions on the Covan testnet. So one thing that needs to be understood is that these environments are completely separate. there is no common transactions or common blocks in between these environments. They are totally different blockchains that have different nodes that run in a different with a different set of transactions. The only thing that's same is that it's the Ethereum specifications that are running on these blockchains. So I had shown my MetaMask wallet details. One thing that we can do as a quick test is to see if I have these many ETHs on testnet or not. So I've copied my address. This is, by the way, my address. And then I try to search with that address. So what I'll see is that the balance is actually there. I have these many ethers available for me to test my transactions out. And it also shows me all the transactions I've made in the past. So the transaction hash that I was talking about is something that you can see here. In fact, Etherscan also has a lot of other powerful features that we will discuss in some of the later sections. So this is the second component that we have to understand to be able to deploy our contracts on the blockchain. Now coming back to our remix environment, the first thing that we have to change is the environment in the drop down. So to be able to connect to MetaMask, I have to select injected Web3 option. What that means is the Web3 that has been injected into my browser through MetaMask. Once I will select it, it's going to automatically load my account with the 35 Ether balance. And that is all that I have to do. I am ready to deploy my contract, which has already been compiled. But the flow is going to be slightly different this time. When I click on deploy, it's going to automatically launch my MetaMask, asking me to sign my transaction. Now, since I already have my account imported in MetaMask, it knows my private key, which is why it just asks me to confirm that it can use that private key to sign my transaction, to which I say confirm, and it just vanishes and takes my transaction forward. After a couple of seconds, you'll see that it's going to show me a notification that the transaction has been confirmed, and it's going to ask me to view it on Etherscan. So I can either go back to my Etherscan view or click it from there. So once I refresh my Etherscan view, I see the transaction that's been added. It was added 19 seconds ago, and it was a transaction of the type contract creation, which means I was successfully able to create a contract on the blockchain. If I open this transaction, it's going to show me some more details, including input data. So this input data is that same byte code that I was talking about. If we go back to this view, this byte code is what is appearing here. These set of numbers and letters, they represent the byte code that I am deploying on the blockchain. If you compare it with the input data, it is going to be exactly the same. So now when I've been successful in deploying the contract onto the blockchain, it automatically shows me the contract deployed with the right address as it had done in the earlier test. But this time it's slightly different because it's going all the way over the internet to a remote blockchain node from where it's interacting with my MetaMask instance and then doing my blockchain interaction when I've just done the smart contract deployment. Once this is done, I'm ready to execute my tests. I'll do the first test, which is going to be retrieve that automatically retrieves 0 for me, the default value. Then let me add a new value as I had done in the last test and click store. Now you'll notice that MetaMask comes up again. The reason for that is I have to sign a transaction to pay for this transaction fees. So the question to ask is, why did it not need me to pay the fees when I was testing retrieve? And I will answer that right after I confirm my transaction. So the transaction is gone and it has been confirmed also. But to answer the question that we just raised, when I was testing retrieve, all I was doing was reading the state of the blockchain, which means that I was just in observation state. And when I'm in observation state, I don't have to pay any transaction fees. But when I have to partake in the update process, then it requires me to pay the transaction fee that results in the update of that blockchain state, which is why retrieve does not need me to sign any transaction, because I'm not authorizing payment of any fees. Having said that, I've already updated my state to 4545 and I sent a transaction. Let's see if that transaction went through. So I'm again searching for my address. This is the contract deployment transaction. All I have to do is refresh my browser and I'll see that the store method call is available as recorded by the blockchain. I can even go to the transaction and look at the input state, and it's going to show me the data that I tried to update. What this means is that my data update had gone through and was a part of the transaction that triggered the smart contract. It just confirmed that I was able to call store with the value 4545. But did it actually successfully update the state? Only one way to find out. I'll call retrieve again and it's going to show me the updated state. So this test is very similar to what we've done in our local deployment, but this represents a lot more because this is the entire end-to-end flow of smart contract development. When we actually develop code for production, we will not be using Remix, but in principle we will be doing these steps only: building the contract, which we just used as a sample contract, compiling it, which we did and saw the ABI, saw the bytecode, and then deploying it, which is where we sent transaction and contract to the blockchain and then interacting with it. So with this, we've at a very high level understood how smart contracts are built and run. The process is very similar in other blockchain flavors as well. So hopefully this gave you the understanding that we need for building more smart contracts. Thank you.